Hey, this is Math 7, Unit 7, Lesson 16, applying volume and surface area. Alright, so here we go. For each situation, decide if it requires Noah to calculate surface area or volume, explain reasoning. So first of all, Noah's planning to paint the birdhouse he built. So he's going to paint the birdhouse, and he's not sure about the amount of paint he wants. Well, because he has a little birdhouse here, whatever that might look like, okay, he's going to be painting it. Because he's painting the outside of that house, all the different surface spaces of it, we would probably say he would want to use surface area. It doesn't matter how much space is inside, he just wants to paint the outside of the house, so surface area makes the most sense there. Next, Noah's planning to use a box with a trapezoid base to hold modeling clay. He's unsure if the clay will fit in the box. So what would he use? He wants to know if it will fit in the box. In the box means we're dealing with the space inside. So that would probably be a good use for volume in that case there. All right, let's go then to number 2. Trying to put all this stuff together here as we wrap up this unit and get close to the end. At a daycare, Kieran sees children climbing on this foam play structure. She's thinking about building a structure like this for her younger cousins, his younger cousins to play on. Oh, so Kieran is a boy. Good to know. All right. The entire structure is made out of soft foam so the children don't hurt themselves. How much foam would Kieran need to build this play structure? So because we're talking about making the soft foam, we're talking about volume in this case here. We want to know the shape itself. So I got to find the volume of this entire shape. So the volume in this case here, because I have a base here, which is a little funky base, but I do have a base. It looks like this. All right, this is my base, and it comes down to here. I have a base. I can find the base here, and then I have a height as well. So the base area, I have a 5, and I have an 8. I have another 5, I have a 10, I have a 20, I have a 2, and a 36. So what I want to do is I want to chop this up a little bit. So I'm going to chop it right there. And that's going to be 8 times 5 is 40. That's easy enough there. Here I'm going to chop it at the 10. So if I chop it there, I've already used up 8 here. Well, this is 10 as well right here. And the height is 5 and 5, that's 10, so 10 times 10 is 100. So I have a 40 and a 100. Here, I'm going to draw a line right there, and so I've already used 10 and 8, that's 18 altogether. So 36 minus 18 actually leaves me with, in this case, 18 left, right? So I have 18 as the length right there, 18. So this space right here is 18 times 2, which is 36. Now if that was 2 and the whole height was 10, we said, that leaves me with a height right here of 8. So this has a 1/2 of 8 times the length there, which is 18. So that's going to be 9, because half of 18 is 9. 9 times 8 is 72. So I can put 72 right there. So the area of this base is going to be 100 plus 40 plus 72 plus 36. That's 8 there, and 14 carry the 1, 248. That's the area of the base. Okay, so we're good with that part. So if we want to find the volume is going to be base times height, right? So we have 248 times the height, which is 20. So that's going to equal 4,960, in this case here, inches cubed. Now it says that this structure is covered with vinyl, so it's easy to wipe. How much vinyl would it need? So we're talking about covering it, so that's going to be surface area. So surface area is going to be our base plus our base plus, and we've been doing this one, perimeter times height. So we know we have a base of 248 plus 248 plus the perimeter. Let's take a look at our perimeter and see what that's going to be. We have 36, 2, 20, 10, 5, 8, and 5. All right, so 5 and 5 is 10, 10, 20, 40, 8 and 2 is 10, that's 50, and 50 plus 36 is 86. So we can write down 86 is our perimeter, times the height, which is still going to be 20, right? So 248 and 248, that's going to be 16, carry the 1, 9, 596, plus 86 times 20 is 1720, which gives us 2,216 square inches for the surface area. Well, that's the idea behind that one. Now in the next question, we're going to continue here. I'm going to keep my volume. So my volume was equal to 4960, and my surface area was equal to 2216. Okay. Alright, so it says foam costs 0.8 cents per inch. Here's a table that shows the vinyl. Alright, so what's the total cost of foam and vinyl? So foam is for the volume. So for the foam, we do 49.60, and we're going to multiply it by the amount of the cost for foam. Now that 0.8 cents, okay, we're not multiplying by 8 cents, it's actually 0.008, right? It's 8/10 of a cent. So we're going to multiply by 0.008. A little bit tricky there. If you just multiply by 0.8, you'll end up with something very off, okay? Because that's not even a full penny. So you got to multiply by 0.008. So 49.60 times 0.008, we have 0, 8, 4, carry the 48, 72 plus 4 is 76, 32 plus 7 is 39, 3 decimals, so we go 1, 2, 3. So the foam is $39.68 for the foam. Alright, now the vinyl. The vinyl here is a little bit different, okay? And so how you did in class, well, see what your teacher come up with, because I came up with a little different answer than what my book said. So here's what I did. I said that you had 2,216 inches to start with, okay? Now, I'm going to buy as much at the 125 rate as I can. So what I did is I took 226 and I divided it by 125, which gave me about 17, okay? So what I did is I said, well, 2216 divided by 125 is 17.728. So that tells me I can buy at least 17 of these at that rate right there. Now 17, I'm not going to put the extra, right? So 17 times 125 means I'm going to use, or I'm going to be able to cover 2,125 of it so far. Okay, so what do I have left to cover? Let's borrow. I'm going to be left with 91. Okay, so 91, can I get it done with one of those? No, that's going to be not enough. I still have more to buy. So we have 8, we have 6, I still have 16 left over. So to me, I'm going to need to buy 2 of these and 17 of those in order to cover the full 2216. Does that make sense? Right? So I divided it to see how many of the 125s I could use, and then I had to subtract that to see what was left. So if I had to buy 2 of these at 45 cents each, that's going to be 90 cents. And I have to buy 17 of these at 75 cents a piece. So 0.75 times 17, that's $12.75. So in total, what I got was $13.65. Okay, so for the vinyl, I got $13.65. All right, so the foam was $39.68, and this is $13.65. So the total cost for everything would be $39.68 plus $13.65. 13 carry the 1, 13 carry the 1, 13 carry the 1, and I have $53.33. Okay, my answer key is something a little bit different, so I'm sure there might be a different way of doing that, but this is what I came up with there and how I got there. And again, if you have a different idea, see what you come up with and think, and just be able to prove it. Okay. All right. Next one. Are you ready for more? When he examines the play structure more closely, Clean realizes it's really two separate pieces that are next to each other. So he went, oops, there's two separate pieces. Oh well. So how does this affect the foam of the play structure? Well, it's still exactly the same, right? There's just a chop down the middle. So there's no change to the volume. That'll be the same. But for the vinyl, the surface area, that's going to have a change. So surface area, you're adding two sides. And what you're adding here is really this space right there. You're adding this little square that cuts between those two. And so it's a 20 by, in this case here, 10 space. So you have a 20 by 10 on both sides. So it's 200. And you add that up, so you end up with an extra 400 inches squared of vinyl needed to cover both sides of that shape at that point. All right, 16.3. Our last lesson part before we jump into the homework. Another problem where when I did this here, the answers that I got were a little different than what I got in the book. So let's see how this works out. Okay, so the daycare has two sandboxes that are both prisms with regular hexagons as their bases. The smaller sandbox has a base area of 1,146 inches and is filled 10 inches deep with sand. Okay, so it took 14 bags of sand to fill the small sandbox. What volume of sand comes in one bag? Okay, well, let's find the volume of the sandbox first of all. The volume is going to be equal to the base, 1,146, times the height of 10. So we end up with 11,460 is our volume. That's the volume of the small sandbox. Now if it took 14 bags of sand, let's divide that number by 14. So 11,460 divided by the 14 is going to tell me about how much sand comes in one bag, because it took 14 of them to get to that point. So 11,460 divided by 14 is actually equal to 819. So it took 819 bags of sand to, or sorry, 819, what volume of sand? Okay, so 819 like inches cubed, cubic inches of sand in one bag. And so it took 14 of those to get to that point right there. Now the daycare manager wants to add 3 more inches to the depth of the sand in the small sandbox. So how many bags of sand will they need to buy? Okay, well, once again, let's take our surface area, which is 1,146, and let's multiply that by an additional 3 inches of height. That's going to get you up to 3,438. Now, if we divide that, knowing that there are 819 cubic inches in a bag, that's going to tell me that I need about 4.19. I probably can't buy 0.19 from the bag, so I'm going to need to buy 5 more bags in order to get up to 3 more inches of depth. I won't have to use them all, but I need 5 more bags at least. And that's the idea for that one. For number 3, it says the daycare manager also wants to add 3 more inches of depth in the large sandbox. The base of the large sandbox is a scaled copy of the base of the small sandbox, with a scale factor of 1.5. How many bags do they need? Now remember, when you do a scale factor of something and you're looking at scale factor of area, scale factor of a length is just going to multiply by 1.5. But because we're doing area, it's length times a width, and so it's also 1.5. So when you do a scale factor of 1.5, you're going to take your amounts and do 1.5 times 1.5, which is 2.25. Okay, so now let's take the area of our base, which is of our small one, 1146, and let's multiply by that scale factor of 1.5, which is actually multiplied by 2.25. When you multiply this one out, what you're going to end up with now is 2578.5. So that's the base of the large one. Okay, now the large one, we take that base and we're going to go ahead and we're going to multiply it by 3 inches. When we do that, we end up with 7,735.5. Okay, that's the additional volume I have to fill with more sand. That's the additional volume. I'm going to divide that by how much inches are in one bag of sand, cubic inches. And that's going to give me about 9.44, which is the equivalent to about 10 bags. So to fill the small one up, I need about 5 more bags. To fill the large one up, I need about 10 more bags there. That's what I'm at so far. Now at the lawn and garden store, they're selling 6 bags of sand for $19.50. Okay, now that also, just as something to think about here, means I can get that. Usually that means when they say this, that means I have to buy 6 to get that price. It's usually what that means. In this situation here, based upon what I see in the answer key, is they're saying, well, then use that to find out how much one bag is going to cost. Well, one bag in this case is going to cost us $3.25. So in terms of the amount of sand that you need to fill both boxes, I'm going to use this number 419 and this number 9.44 to see how much total sand I need to have. So 419 plus 9.44, 9 plus 4 is 13, 4 plus 1 plus 1 is 6, and then 9 plus 4 is 13, right? So I need 13.63 bags total, so I'm going to need to buy at least 14 bags. And 14 bags times the price of $3.25 a bag, it's going to be $45.50. All right. So again, those are the answers I came up with. Just going through the process there. Is it perfect? You might get something a little different, and that's okay. I mean, it probably should be just one answer here, but just that's the logic I used to solve this one here. If you find a mistake, again, fantastic. Way to attend to precision. That's great, great work. That's what it's about. So I'm going to stop there for now. Do your homework, and once your homework's done, then you can come back and check it with me in just a second. All right, homework time. A landscape architect is designing a pool that has this top view. How much water will be needed to fill this pool 4 feet deep? So we're talking about volume again. So we're going to want to find the base times the height. So the base area, it's a little bit of a funny shape. So let's fix the shape a little bit by decomposing it. So this becomes 9, which makes this space right here 2. This is 1.5. We're going to chop that off right there. 1.5 right there, which means I do 12 minus 1.5. That tells me this height is 9.5. All right, so 9 times 12 in this space right there is equal to 108. In this space right here, 1.5 times 2 is equal to 3. And in this space right here, we have 1/2 of the base, which is 2, that goes away, times the height, which is 9.5, oh, 9.5, 10.5, I'm so sorry. So 10.5, do my math right there. So 10.5 right there. So the area of the whole thing is 108 plus 10.5 plus 3. So we have 11 to 121.5 is our area. That's the surface area. Now the height we said was 4, so I'll multiply 121.5 times 4. We have 4, 6, 8, 4, and 1 decimal. So it's going to take 486, and we'll say cubic feet to fill up the whole thing. Before filling up the pool, it gets lined with a plastic liner. How much liner is needed for this pool? All right, so to do this right, we're going to need to do the base, right? And now, because we're doing the line on the bottom of the pool, I only need one base. So I'm going to do a base plus the perimeter times the height. So our base is 121.5 plus the perimeter. So the perimeter in this case is going to be what? 12 plus 9 plus 10.7 plus 1.5 plus 11. So that all adds up to be 44.2 times the height, which is 4. So we do 121.5. I don't have to have a top liner. This is just, there's only a bottom of a pool. And we're going to add that to 44.2 times 4, which is 176.8. When I add those up, I get 298.3. So that's what I got for my solution there. Yours could be a little different, but that's just where I am with it. So here are the prices for different costs, different types of liner, or different amounts of liner. How much will it cost for this? So again, what I want to look at is how many 75s can I get out of 298? So I do 298.3, and when I divide that by 75, 298 divided by 3, divided by 75, here's where you end up with. You get 298 divided by 75 equals 3.97. Okay, so I can definitely get 3 of these guys right here. So that's 3. So now let's subtract. So 75 times 3 is actually what? It's 21, 22, 225. So I'm going to subtract 225 to see what I have left. I have 0.33, I have 73.3 left that I still have to cover. So that means I can use one of the 50s, and I'm left with still 23.3, which means I need one of the 25s. So 3.75 times 1 is going to be 3.75. I need one of those. I need one of the 750s, check, and I need 3 of these. So real quick, 11.25 times 3 is 5, is 7, is 33.75. So I'll put that right here. When I add that up, I have 10, carry the 1, 14 plus 6 is 20, carry the 2, and I have 10 plus 5 is 15, carry the 1, and so I would say $45 is what you need to make this work out okay. $45. My answer key says $44.75, but that's off by 25 cents. I'm not sure where I went wrong or where something is a little bit off, but that's how I did it, and I've done it a couple times now, but that's okay. Alright, shading the base of the trapezoid prism. Have the next page. Be careful, the base is not the same as the bottom. Sure. Okay, so let's take a look here. The base of this trapezoid prism is going to be right here. Right there. There's our base. Find the area of the base that you shaded. Sure. Well, the base is that shape that looks like this. And we know we have 4 there. And we know that the whole thing was 8, but this right here is 5, which makes that a 3. And so 5 times 4 for this space right there is going to be 20. And this will be 1/2 of the height, which is 4, times 3. So that's going to become 2 times 3, which is 6. So the area of the base is going to be 20 plus 6, so 26, whatever. The volume then will be 26 times the height, which is 26 times 12. And that's going to equal 312. Cool. And moving down here. Decide if it's an increase or decrease and determine the percentage. Alright, so we can see that it's getting larger, so that's going to be an increase there. Each one of these is about 33%. And again, it's about 33 and a third percent. So because it's increasing by one more of the thirds, we would say it's a 33 and 1/3% increase. Here, we can see it's increasing by two of those. So we would say that that's going to be an increase, and it's probably about 66 and 2/3% increase. Okay. If you just want to say 66%, that's probably just fine too. Here we're taking away one, so that's going to be a decrease of 33% or so. And here we're taking away 2, so that's a decrease of about 66% or so. Something along those lines there. And number 4. Noah is visiting his aunt in Texas. He wants to buy a belt buckle whose price is $25. He knows that sales tax is 6.25. So how much will the tax be? So if I just want to find the tax, I'll do $25 times the tax rate, 0.0625. Again, move that over 2 spaces, right? 2 spaces. So 25 times 0.0625 is $1.56. That's the tax. Now how much will he spend on the buckle? We're going to add that to the $25 that costs, and you have $26.56. Write an equation that represents the total cost. Well, the total cost is going to be equal to, in this case, we'll do our tax, but I want to do the actual price, right? The 100% plus the 6.25%. So that's going to be written as 1.0625 times the price, right? That's my 100% and my 6.25%, all in one big number there. All right, let's look at, that's actually it. So that's it for today. That's it for this unit. Good luck with upcoming tests, and we'll see you in the next one.